Okay, so in today's lesson, we're going to do kind of a two-part lesson, what you learned before, and then what you're going to learn now for lesson one. So in the what you learned before, I'm going to kind of go through some of it, but honestly, because you've learned it, you should know how to do this. So just to review in number one, when we evaluate expressions, we are inputting a variable or substituting a variable with given numbers. So in this one, you are given the numbers x equals 3, y equals -2, and z equals -1. So when I substitute those in, I'm going to put parentheses for anything that shows multiplication. Putting in a 3 for x, a -2 for y, and then because that z has a subtraction sign, we also want to include that in parentheses. I'm going to simplify this down, so I get -6 plus 6 divided by -2 plus 1. And then I can simplify down that 6 divided by -2 to -3. And when I put this all together, I get positive or -8. So -6 and -3 make -9 plus 1 is -8. You can finish numbers 2 and 3. Moving on to plotting points. I do not think this is anything that I need to review with you, other than you are plotting all of these points in quadrant 1, and that you need to make sure that you include each of the labels with the points for the letters. So when you do number 1 and plot 3, 3, you should also be marking that T. Go ahead and finish all of 1 through 10 for plotting those points on the coordinate plane, just to refresh your memory. And then last in the what you learned, we're going to go back through and talk about solving for y. So taking a look at number 1 in solving for y, remember everything we want on the right should be everything but the y itself. So the first thing we're going to do is we're going to move that 3x by subtracting it on both sides. And remember, the overall goal is to get the form y equals mx plus b. So when I move that -3x, I'm going to put it in the first space, and we're going to move that 10 behind it. So in that next step, I'm going to take and I'm going to divide each term by -2 so that I can simplify down to y equals. -3 divided by -2 becomes 3 over 2 x, and 10 divided by -2 becomes -5. Moving over to example 2. Start with that x term first. So we're going to subtract 4 from both sides. Bring down your -2/3 y. Put the right side in the correct order with the x term first. Don't forget about your negative and positives. And then we have a fraction. When we want to clear a fraction, we multiply by its reciprocal. So everything is going to be multiplied by -3 over 2. This allows these terms to go to 1, which remains y. And we can place these over 1 so that we can easily say, well, -3 over 2 times -4 over 1 still has the x attached, plus -3 over 2 times 10 over 1. And then I would go back and I would simplify more. So y equals, this 2 turns to a 1, that -4 turns to a -2, and I can multiply to get 6. Keep the x. This 2 turns to a 1, the 10 turns to a 5, divided by 2, and then I multiply -3 times 5, and I get -15. I want you to try number 3 on your own. So in the what you learned section, you should have the top 2 plus the coordinates, and then number 3 in solving for y. So you can pause this and work on those, or you can choose to go on. We will go over those in class together the next day. All right, so lesson 1, graphing linear functions using tables. So this is something that should look pretty familiar to you. You have an XYT table that's going to create ordered pairs for you, and then you are also going to plot those pairs and get a graph. These were part of our functions chapter, but we're going to just address them again to start and connect our chapters together. So a linear equation is an equation whose graph is a line. The points are solutions of the equation. You can use a graph to show the solutions of a linear equation by the graph represented below with y equals x plus 1. And if you notice, this right here is in the format y equals mx plus b. And then you can see right here, you have your ordered pairs as well as your linear equation. So let's move down into the first set of examples. You're going to decide whether the given ordered pair is a solution of the equation. So let's review what an ordered pair represents. An ordered pair represents an x and a y coordinate. And over in your equation, you have an x and a y variable. So you are simply going to substitute. And when you do that, you get -3 times 2 for the x value plus 6 times the y value, which is -1. And we are looking for a solution of -9. But again, we're deciding whether the given ordered pair works or not. So when you work this out, it may equal or it may not be equal. So we get -6 minus 6 equals -9, and -6 minus 6 is -12. 12 does not equal 9, so the answer is no. It is not a solution. Let's move on and go to number 2. In number 2, you are given the ordered pair -1, -1. So you're going to substitute in again for x and for y. 2 times -1 plus 9 times -1 is going to equal -7. So that's what we're checking to see. So I get -2 minus 9 equals -7. That equals -11. So it does not equal. Therefore, this ordered pair is no, it is not a solution. You can go ahead and try number 3 and number 4. Those are just like that. And I'll talk about number 4 before we move on. So in number 4, it just gives you x equals -4. So when you look at your ordered pair, you can see the term that you need is 1. So is 1 equal to -4? It is not. Therefore, no, this is not a solution. You can go ahead and also complete number 6 on your own. In example 2, we have graphs. So you're going to use the graph to decide whether the plot lies on the graph of the line. So again, we're just checking these ordered pairs to see if they fall within the graph. So when I look at number 1, I have a line already drawn on my graph, and we are going to take the coordinate pair 1, 0. So over 1, up 0. And that orange dot falls within the line. So does the point lie on the line? The answer is yes. I believe you can go ahead and try number 2 on your own. Moving ahead to examples 3. So these are the T-charts. You should be familiar with these from 6th grade, and they were also part of our functions chapter. So I'm going to go ahead and do number 1 just to kind of go through those. Where do your x's come from? I feel like this is the most frequent question I get. They are simply made by you. So my general rule of thumb is that I pick negatives, 0, and positives. So I can see I have 5 blank spaces here. So I'm going to go ahead and pick -2, -1, 0, 1, and 2. And I'm going to use this blank space to substitute my variable in. So I'm going to say 3 times -2 minus 2. So that equals 3 times -2 is -6. And when I subtract 2 from that, I get y is -8. And I'm going to continue to do this down my T-chart. should be noticing that as you do this, when you have an equation with the format y equals mx plus b, like you do up top, that your y and your x should see a pattern. And then to double, triple check that, you are going to go ahead and take those x and y's and you are going to place them on the coordinate plane. So I have -2, -8. I have -1, -5. I have 0, -2. I have 1, 1. And I have 2, 4. And if you notice, while I am plotting these points, they do create a line, which they should, because you have a linear function, which is y equals mx plus b. You can go ahead and try number 2 on your own, and number 3. And I'm going to go ahead and do number 4 since it has a fraction in it. With that, don't let the fraction be scary, but if you have a fraction and you're going to be inputting a value for x, you want to choose carefully when you choose those x values, meaning I don't want to choose a whole number value that isn't going to clear a fraction. So for instance, I'm going to choose a value that wouldn't be very well liked by this function. So if I were to choose the number 4 and I put it in for x, I end up getting 4/3 minus 2. While this still works, later on when we do this, it's not going to be very friendly. And look right here, that's going to be a mixed number. Nobody wants to plot a mixed number with a coordinate of 4 and a fraction. So this is why you want to avoid picking numbers that don't clear the fraction. So let's review how to do that. When I have a denominator of 3, I want to pick numbers that have a factor of 3. So for instance, if I pick -3, actually let's take that back since I have to pick 5. I'm going to pick -6, -3, 0, 3, and 6. So how did I automatically know to pick that? Well, I know my fact families. I know that 3 has factors or multiples of 3, 6, 9, 12. So when I go ahead and I say times -6/1 minus 2, you can see the 3 is going to become a 1 and the 6 is going to become a -2. And when I have everything else as a 1, I get -2 minus 2 is equal to -4. And now I have a coordinate pair with a nice whole number. When I use that -3, place it as -3/1. Those 3's both cancel to a 1, and I'm left with -1 minus 2 is equal to -3. Now 0, although not a multiple of 3, it will automatically clear a fraction because that will become a 0 minus 2. And if you notice, I have a slight pattern going down the side, so I can double check my work, knowing this should probably be a -1. This should probably be a 0, but let's check it out. So we have 1/3 times 3/1 minus 2. Those become 1s, and I get 1 minus 2, which is equal to -1. 1/3 times 6/1 becomes a 1, becomes a 2, so I have 2 minus 2, which is equal to 0. And now I'm going to plot those points on the coordinate plane. So I have -6, -4. I have -3, -3. I have 0, -2. I have 3, -1. And I have 6, 0. And you should have a linear graph due to the fact that you have, again, that y equals mx plus b format. So in number 5, what happens when I don't have y equals mx plus b? Well, you have already learned how to change that around, so you have to do that first. So in this one, we're going to move those two x's first. It's going to leave me with negative 5y equals negative 2x plus 10. I'm going to divide every term by negative 5. And that gives me y equals 2/5 x minus 2. So again, I have that fractional part. So I want to pick x values that get rid of the fraction with a denominator of 5. So I'm thinking of numbers, multiples of 5, to pick my x values. Go ahead and you pick your own and finish this one out. Remember, you probably want to pick 2 negatives, 0, and 2 positives for this column, and then finish out that problem, as well as finishing out number 6, which is a lot like number 5. In example number 4, we have horizontal and vertical lines. This should give away what you are plotting on these graphs. You are literally going to take these coordinate points and you are going to plot them. I'll do the first one. So we have 3 to the right and up 1. That is ever so hard to read a little bit. Okay. And then 3 up 2. And 3 up nothing. 3 down 1 and 3 down 2. And if you connect those, you have a vertical line. So this is vertical. Although it looks linear, we're going to talk about these special scenarios in this chapter. So you can go ahead and graph this second example. And then let's take a look at the last section, which is example 5, a graph. How do I get these on the graph? Well, I look at my value and I plot that point. So if y is equal to 2, I'm going to find my y-axis. I'm going to go up to positive 2, and I'm going to plot a point, and I'm going to draw a line through it. Anything that you plot on y should be horizontal. And then the opposite, anything you plan on x should be vertical. So when I look at this, I have my x-axis. I go to negative 4. I place my dot. And I draw my line. So again, if it says y equals, you're going to end up with a horizontal line. If it says x equals, you are going to end up with a vertical line. So you guys can go ahead and do numbers 3, 4, 5, and 6. And anything that I've asked you to do as practice today virtually, you're going to bring this back and we are going to go over all those together in class the next day. Please email me if you have any questions over any section, being specific as to what number you're talking about.